So we're good?
Yep.
Cool.
We are set. We're in place.
All right.
Ready to go.
So this is going to be a talk on architecture without a framework with a heavy asterisk on it. So a framework is good for probably 90% of the projects you're going to want to work on. It's probably a safe place to start. This is more oriented towards thinking about something as an enterprise or a SaaS, and you want to maybe think about the core business concerns first, and then the details that are sort of a necessity for that later. So it's a highly opinionated talk, and it's also sort of rushed, so things aren't going to be fully fleshed out. So I wanted to be more conversational around that. An important thing to note is that we stand on the shoulder of giants. So Alistair Cockburn is responsible for the concept of hexagonal design and how that interacts with like this adapter sort of pattern. Jeffrey is responsible for onion architecture, which sort of sets up boundaries between different layers of your software. Robert Martin, he has a really good book called Clean Architecture that you should check out. He's pretty heavily opinionated, and he's pretty rooted in sort of Java and compiled languages. So you sort of have to take a mental context to separate that, and I'll go into that a little bit. And then Martin Fowler is just a badass. The man's he's really good at public speaking, and he writes really good books. His delivery CI/CD book is kind of dry, but that's infrastructure. He's got a good refactoring book, and he's got a good patterns of enterprise application architecture book. So these guys are sort of where I've modeled a lot of my data from. As I was putting this slide together, I was like, that's a bunch of older white dudes as I looked at it, but hey, we've got a demographic issue in our industry as well. So what we're going to look at is some examples of architecture in the wild and very popular applications or code bases and some unpopular ones. They're not all going to be dumpster fires, but some of them certainly are. So we'll take a look. So the first thing is we're going to run through this and kind of say, I want you guys to tell me what this does. This is the root of the repo. What is this repo responsible for? Not a lot of meat on this bone. So, okay, I'm going to dig into the framework because that seems like the most logical place to go next. Okay, now what does this thing do? All right, so we've got assert, we've got this mock object, assertion failed error, code coverage exception. What are these things for? Any ideas?
Unit testing.
Unit testing. It's a unit testing framework. It's PHP unit. Okay, so that told us what it does. All we had to do was look at it. So this is the concept of, and Robert Martin goes over this, scream your architecture. Your code, the way your code is laid out, should tell people, developers, what it does. And it should be a high-level view, and as you dig into the classes, you should get those low-level granular things. It should be very easy to consume and understand what your code does. So this is an example of not a dumpster fire, I think. This is pretty well put together. Nothing wrong with this. What about this one? What does this do? Auto load, console, dependency resolver. Any ideas?
Looks like it does everything.
It's a framework.
For what, though? So this is Composer. So it is the autoloader. And at a high level, it's a little hard to see it. There is files in here that will say Composer in them. So if you know what Composer is, the context is immediately there. I think this one does a fairly good job. As you dig into autoload, you start to see that this isn't auto-loading, it is the autoloader. Those kinds of things start to become apparent. How about this one? And this is the top level directory, and this is it. There's nothing more in this repo than this. I obfuscated the class that was called what the repo name was, and I think that's a giveaway. So this is Carbon. Anybody familiar with Carbon? Okay, so I'm going to shift some context here in a little bit, and we're going to look at the Carbon repo. In fact, we can do that right now. So this is Carbon. This is it. We've got an exception. It's an invalid date exception. That seems appropriate for a date wrapping library. you got your language files. And then if we dig into the Carbon file itself, we find that it's massive. We've got almost 5,000 lines in one class. Probably not good architecture. Maybe you can argue that this makes for an easy to consume API, but in all honesty, probably not. You could probably have more descriptive classes that resolve themselves out of this main class and have it much more readable, because this is the kind of class that I think you only really get to understand when you've attached a debugger and you're walking through your code setting up examples. Otherwise, you've got no context. I mean, we could probably pick anything and be a little confused. Max value, probably not confusing. Create safe. Safe what? What does that mean? So you got to go through and you're like, is it a safe time? So on and so forth. You got these fun old sort of principles embedded in there. So probably not good architecture. Maybe useful. It's clearly functional and everybody is familiar with Carbon, or a ton of developers are familiar with Carbon. But at the high level, probably not so good. How about this one? I have no idea what this does. It's an app, but it's got a CLI end, and it's got P. What the hell is P? Like, why is that there? What is your purpose? So I dig into it. Okay, so this is like a front end sort of thing. It's got an API. It's got I. It's got F. What the hell are those? Why are those there? No developer is going to be able to just pick this up and understand what they're working with. And when you dig into the code even further, it's more of a mess. This is a fairly popular RSS reader. It's got a lot of stars on GitHub, lots of people use it, lots of contributions to it, but not good architecture. And that's okay. So this is an example of success in spite of bad architecture. Totally possible. You don't need this really well built up, really well thought out system to be successful. But if you're maintaining a not well thought out, successful system, you're going to be having a nightmare of trying to deal with these coupled dependencies and obscure classes and obscure functions. So it's not just for you, it's for the future developers that you leave a good code base. You want them to be able to pick it up and be successful in their work. So we're going to go over some terminology, and this is the series of slides that are sort of wall of text, unfortunately. But we're going to talk about boundaries and components, layers and levels and how they relate, the rules and principles and patterns that we can sort of use to build good architecture, this concept of policies, entities and use cases, and then we get into more low-level concerns around interfaces, frameworks, and drivers. So components don't exist in PHP. It's not a concept that you'll see in any documentation. It's in the developer's mind. And it's logical grouping of related code. You can maybe put them in folders together. Maybe they share a namespace and they can be spread out across folders, but they're somehow grouped together so that you know what the context of that component is. And boundaries are a way of segregating the components. And the boundaries are tightly coupled to the dependency rule, and we'll get to that in a moment. So we'll talk about layers and levels. So this is the onion architecture, overly simplified. You'll see the black arrows pointing inward. What this basically means is, so say you're in the controller gateway or presenter layer, the green layer. You're not going to know about anything from the layer below you. You'll never see, and this is sort of violated a lot, a database in the controller. You won't see your views in the controller. You'll build stuff up and you'll hand it back over to the layer that deals with that sort of stuff. So let's go ahead and get into the don't panic slide. So this is reference. This is for you to sort of take away from this. We'll have the slides after, and this gives you a lot of Google material. What you'll see in principles is we've got solid. And you're probably all familiar with solid principles in some form or another, single responsibility. A class should only do one thing. A function should only do one thing, generally. It's kind of loose. Open-close principle. class should be open for extension and closed for modification. In other words, once you're done working on it, if you need to add functionality to your application, that should be an extension of that class. This is a really hard one to stick by truly, because what if you have a bug? What if the functionality that you're adding to it directly affects this class? It's okay sometimes to modify it, but it's a principle. Liskov substitution principle, which is terribly named because it's named after a person. It's just being able to substitute one class for another, generally because they're under an interface. Interface segregation principle is similar in its nature. Things should be separated by their interfaces, and that applies to functionality. And then the dependency inversion principle, which is a pretty core component of clean architecture in this talk, which leads into the flow of control, the flow of dependency. You shouldn't have something on a lower layer depending on something on the above layer. Instead, you should go through an interface and sort of use that as your abstraction point. Think of it almost like a pivot table in like a relational database, where you've got two arrows going towards each other versus, directing at each other. Sort of a bad analogy, but the things on the right to pay attention to is the dependency rule, which I sort of talked to a little bit there. Don't repeat yourself, be polymorphic, and that involves interfaces. And then follow the flow of control and use what are called humble objects, which are sort of dumb objects. They're plain data objects that you can mutate things into and pass them around the layers. And this ensures that your different layers don't inherit functionality from the other layer because they've used a common object that doesn't have behavior. It just transfers state. And then the strategy pattern I won't go into. So policies are the way of saying what your application does. So, or it tells your application what to do. It's a declaration of your company's policies, for example. You want to separate policies from each other and group them in ways that if a piece of software changes, the things that change near it are the only things that change. You don't have some other layer in some far off component or class that need to change because of your policy change. That's easier said than done. It's really hard to determine where the policy boundaries need to be. So we'll talk about entities and use cases, and this is in the context of the clean architecture way of doing things. So entities hold business logic that applies to all of the company across all of the applications. Like, if you're an alarm clock company, sunrise is always when the sun comes up, kind of thing. That's a bad example, but that doesn't change. It applies across all of the company. Use cases are application-specific business logic. So what that means is that you could have two totally different applications that have different behavior because they apply to people differently. So managers versus consumers, stuff like that. And that can be the use case level logic. And then interface adapters. So this is sort of a way where you can layer your architecture and create business entities from those plain objects, the humble object pattern, or it can come in through an API or anything, goes into these common objects, and then you can create entities from that object, and vice versa, you can create those objects from that entity. Sort of the transportation object of the architecture. MVC fits into these interface adapters. So you never have business logic in a controller or a view or a model. And this is commonly violated in MVC. And we have some examples of that we can show. So if we look at this is Laravel. So all of the Laravel is a ton of different components, but this is the core of Laravel. And anybody who's familiar with Laravel is familiar with this structure. This is not Laravel, but it's the exact same structure because it uses Laravel. So somebody walking into this, reading it, says, okay, well, I know this is a Laravel app. That's all they know at the high level. So where do they go to get to the business logic of what's going on? Well, if you know Laravel, you know this is generally in the app folder. So you start digging in there and you're like, okay, so CRM is customer relation management. You got some jobs going on. policies. That's interesting. And you can sort of dig into this. And now you're on the exploration. Whoop, that didn't work. We go back up. And so you're digging and trying to find this logic. Finance, that's new. Okay, well, we got some account stuff. And immediately we see that these are models. Okay, well, so they're keeping the models in finance. And we're tightly bound to eloquent at this point. And if we look at the logic on them, it's all very eloquent-y things. Except this, get balance. There could be some considerations here that, like this, type income or expense. Okay, so, and those get wrapped up and summed. This is business logic. This is right in the model. Okay, so if for whatever reason you want to divorce this framework, you have to extract that business logic and put it somewhere else. So this is very common, and this is clearly a small project. It's probably okay that they do this, but you have to realize when you're doing it that you are setting yourself up to be tightly coupled to that framework. So you're like, okay, well, is that something that the business wants? You know, and as developers, you're thinking on behalf of businesses. They don't know the technology, they don't care. They want it to work and get done well and quick. But there are patterns that you can do to set yourself up and future developers up not to be in the pain of divorcing a framework. So 5 years from now, 6 years from now, is Laravel going to be the de facto PHP framework? Maybe, maybe not. You might want to pivot. You might want to completely take out your code from a framework entirely, and that becomes a nightmare. So that's just one example. We've got another one here. This is a beauty mail for Laravel 5. Makes super easy to send beautiful responsive HTML emails. I think it's kind of rude that he didn't make that for the rest of us to enjoy as well, but this one actually makes a lot of sense as a Laravel app. It's very specifically pointed to be something that people who use Laravel utilize. Okay. He's probably got some facades going on in here. He's probably got some provider stuff going on in here. So let's see, dig into here. All right, so yep, he's registering his facade and provider, and he's got like this core logic that's bound to the Laravel mailer class. So this thing is fully bought into Laravel, and so be it. Yeah, he's using pending mail, so on and so forth. Okay, but it's definitely not coming out of Laravel. That will forever live in Laravel. At that point, it's just easier to rewrite outside of it. This one, calculator. So I don't know what this is, some regulator, I don't know. But this is definitely inside of the Laravel idea. We got controllers in here, which is kind of weird, but that's all right. So we dig into here, we've got our facades, our validators. Here seems to be the core. You register the service and the provider. So what's the service do? All right, tightly coupled to repositories of Illuminate. All right, so this isn't getting away from Laravel, and it's got a lot of rules in here. So this is the default for projects, is to become immediately coupled to these frameworks. It happens without people giving it a second thought. And then there's WordPress. I don't like working in WordPress, but I do like WordPress. At a high level, you understand what it does. It's got its own history. The thing that I don't like about WordPress, and this happens when you're developing software, if you're thinking about developing software for people to use for years and years to come, you end up with legacy concerns. This is a plugin for WordPress. He's got all of his language definitions at the top level, and then he's got one file really. And this limits login attempts. Well, I can understand what that does. This file is huge. So you got 1,000 lines of just functions and global declarations in the global space of PHP. This is the baggage you get with old legacy code, and that's what we're trying to prevent people from writing today. So that in 5 years, we look back and we say, oh, that was actually pretty reasonable. So I don't want to rag on WordPress too hard. They've done a good job, but this is the history to not repeat. Then we've got another example. It's much the same. They've done a little bit better breaking it out, but same problems. And we'll move on from that. So let's dig in. So this is the composer file that I used to initially start this. I did want to bring in PHP unit just because testing is good. And a testing framework is good. See, I don't hate frameworks. Frameworks are great. Just use them in the right places. This should be in the required dev, but oh well. We don't want to install PHP unit on production, right? But all I did is use PSR4. PSR standards are wonderful. And I'm telling it to use the current directory in this namespace, source directory in this namespace, and that's all I've needed to tell it. So this application is a fridge inventory application. I'm gonna be honest, not a lot of thought went into this. I was like, asked my wife, is what would be useful? Fridge inventory. Okay, so that's at the highest level. So this is what it looks like. I've got a source directory, and of course you dig into the source, and you can see that I'm exposing the clean architecture patterns in a very readable way. You don't have to do this. You don't have to have a gateways folder. You don't have to have a plain objects folder. You don't have to call it use cases. You can make it more expression driven to where they have a better understanding at a high level. But this is interesting because if everyone knows the architecture, everyone has a common baseline to read off of. Probably more idealistic than realistic. So if we dig into the entities, and if we remember the description, entities are the business rules that are shared throughout the company, throughout all applications. This is the core business rules. So we know that we have business rules for barcodes and recipes and something called temperature regulators and items, and of course we're using interfaces because why wouldn't you? So I got to point out the temperature regulators because what's a better name for a fridge and a freezer? Like, what do you call those? I thought about it and I was like, it's a refrigerator, but that's not a freezer. So I had no idea what to call the parent of a fridge and a freezer. It's a temperature regulator. You could have coolers in there, but then what about your pantry? So probably poor naming. But anyway, you've got your fridge and your freezer, and those are going to have some form of business logic within them. And we have this concept of a regulator aggregator that sort of groups them together so you can pass them around. These are sort of things that you would need to do no matter the application, no matter the framework. You're sort of working from the top end backwards, and if you meet a framework along the way, then you use it. So we'll look at the gateways. A gateway is a lazy way to get across that we're working with a database. So I didn't go with the repository pattern because it's too bloated for this conversation. But basically we've got our gateway interface, which has a persist and a retrieve on it. And it is coupled to the database or whatever data store that you're using. Could be Redis, could be Mongo, could be flat files, doesn't matter. In this case, I went with the SQLite database. And so that's it. Things will go to the gateway. And if we remember when we look back, that lives in this green layer. I don't have the diagram that names each of the layers. I probably should put that up there. But that's where the responsibility is. And it interacts with the database over an interface. So the use case doesn't know about the database. It'll know about the plain objects that come out of it. So we'll go back to there. So inside of those, we'll see, I guess I skipped it. We'll do use cases. I should have had the plain objects open. I guess I forgot a slide. We'll go back for a second. So inside of the plain objects, I have just one object right now that you'll see when I demo the code. And that's the recipe object. And the idea here is that no business logic lives in that object, just the object's state. And the gateway will pull the information out of the database and it can pass it back to the controller. And when the controller elevates that concern to the use case, it'll use a plain object to store that state and hand it off. And that's where it'll sort of become an entity. We'll see that in code. So for the use cases, these are a couple I thought of. You're going to want to know when things are expiring, so you'll need some form of notice. Maybe you want a generator that sort of knows the inventory of your fridge and creates recipes for you and sends them to you and says this is what you're having for dinner tonight. Kind of creepy, but maybe helpful. And then you've got your recipe use case. Like when you're on an app or something, maybe you want to be able to rate it or like a recipe, things like that. So let's go ahead and demo this, which is always a good idea. So ignore this guy. We've got this concept of controllers at the top. We've got our source, tests are obvious, vendor is obvious, and views are obvious. So nothing here is surprising. I've got these three files, main, API, recipe, and API. That's just because I don't have a routing layer, and I don't want to have a routing layer. This is demo purposes only. So we'll dig into the source, and I'll show you that plain object. All right, so on our interface, we see that you can add likes and get likes and set a rating. And that sounds sort of business logic-y, but when you look at it, it's really not. So apparently I don't have this thing set up for PHP 7 right now. Might as well do that while we're here. Live demos. Okay, so now that looks less horrible. So we're just injecting title, description, and this recipe interface. If you're not familiar, variadic functions basically pass them in one by one on the creation, and then they group themselves into an array in here. And then really what we're doing is, this is a getter, probably should have get, maybe not, maybe so. It just returns a title, returns a description. This add likes is just one by one adding. There's no business logic here. There's nothing saying, you know, should you be allowed to add this like for some reason. It's just adding it. Same for the rating. These are just setters and getters. And then we've adhered on our interface to a serializable interface. So we're just extending that interface. And because we're doing that, we can then say JSON serialize, and when we JSON encode this object, out comes this as an array, and then you just JSON encode that array, and it's a JSON object. So that's all this is doing. So there's no other objects that this depends on except for these recipe items that get set to items. And you'll notice that I'm violating my own rule because this recipe item interface is an entity. So I violated that layer. And I did this as a demonstration purpose, and also I was running out of time. So it's just in here, and now you have entity layer concerns that have crossed the boundary from the use case. It went from entity use case down to the gateway layer. And now the gateway knows about the entity. And with that, the gateway knows about business logic. So this is a violation of the dependency rule, in which lower layers should not know about higher layers. All right, so let's go look at that entity though. Because if we look at that entity, we can see that that item interface adheres to the same serialization interface. And then that item has its own serialization. So there's a recursive serialization happening when you call JSON encode. Any object that adheres to the interface runs JSON serialize, and you get a big happy object out of it. Inside of here, we don't have any business logic going on in the item. The only thing that we really have business logic going on inside of is our recipe item, or our recipe. So, for example, in here, you can only rate this if the rating is less than or equal to 5. So if the business says, I want 6 stars on all our recipes, you just come in here and you say, okay, 6 stars, you have it. And that's it. That's the only place you have to change it, and of course your UI to reflect that. So this is where the business logic is. All right. And the same property of interface adherence happens with all these. There are tons of different ways to go about this. It's just the lazy man's way. So, all right, we've got that. Say we did something much more complicated than this offers. We've encapsulated it totally agnostic to any framework. The only thing we're tied to is PHP itself. And now we decide, all right, we've done this work. I've gotten down to this level, and I'm starting to write routers, and I'm like, this is dumb. This work's been done before. Like, my work, the core business logic is already handled. I shouldn't be writing a router, so I'm going to pull in a router component. Oh, well, okay, that has a middleware, and that's good. All right, I need a validation, so I start pulling it in validation, and pretty soon you're like, this is a job for a framework. So I'm just going to pull in the framework. All right, so ignore these. I was messing with things. There's nothing in here specifying that a framework is required. This could be a flaw in understanding if you want to look at it that way, but we do have this framework controller, or framework folder. So if we bust it open, now we look like Laravel. Okay, so at the high level, they knew more about what this app was about than being burdened by the concept of the framework, but then they understand quickly that there is a framework, all right? So I've got a recipe model and a user model because that's boilerplate. But if we look at the recipe model, it's empty. I'm actually cheating. So I'm keeping, I didn't decide to go with Eloquent. I ran out of time. I didn't have time to wire up my models. So instead I'm cheating and I'm going straight to the controller. So I've got a recipe controller and I'm just newing up some instances. So I've got to create a barcode, an item, inject the barcode. You'll see that these are entities. Oopsies. So we've got a violation of the principle again, but we do also have this plain object. These should all be plain objects. But I'm just building these things up, and then I create my use case. And then from that use case, I can do my business logic. Nothing's changed. The business logic is still fully encapsulated, external of the framework, and I can use the framework to access my business logic. It's perfect. It's like dating instead of marrying. So you go into here and you say, there's nothing magic here going on, except this should be an interface. Nothing magic going here. You just say, okay, this is a use case. So now we've landed in a different part of the layer. So if we look at our use cases, oh, there it is. Okay, so I'm using a use case as sort of a glue between the business logic that's shared across all applications and the one for this application. Felt cleaner than going straight to the use case. So I'm newing up an entity. This is where my entity gets built out of the interface that came in. You could maybe pass it the whole plain object and have it build itself up. I'm just injecting title and description. And then you just say, okay, go ahead and rate this. And if you do rate it, go ahead and set the rating accordingly. Okay, so notice that I'm mutating this dumb object, right? There's no mutating the entity. The entity just told me I could, so I updated the object accordingly and I returned that object. So there's a strict separation between these two. The business logic does not go with the view layer concerns, does not go with the database layer concern. All right, so we go ahead and we return that, and that ends up here. And you start to get like maybe some mental context shift where you're like, oh, I don't know what calls this. Part of me is like, just use your IDE, right? So we can see that we've got our recipe controller. Is this the right one? That's the question. Yeah, so this one we'll try to rate it. Let me make sure I'm in the right place. Yeah, there were different controllers. All right, so this one has a rating of 6. So what's going to happen here is this recipe object does not get updated with the new number, and then we display it. So we're going to look at a couple of things here. Where did you go? All right. So this tab is my dump file that I created that I'm just dumping out the stuff. So if we were to look at that inside of here, it's just on the controller level. We've got this idea of API, and we've got the recipe controller. It looks almost identical. This is totally unrelated to Laravel, and all it's doing is trying to set the rating to 6 and then dump it. We can see that this is the PHP object. We can see that the rating is 0, so that didn't work. If we go ahead and change this to say 5, oh, it's going to be annoying, but we'll do it. We can see our rating changed to 5. So the business rule is working. We could test that on a unit test level. We can test that through Selenium. We can test it through component testing. It's testable in all sorts of different ways. And then you can see that the JSON object creation is working. Okay, everything's happy. You can put this in the database at the controller level. Say, take this dumb object and persist it to the database. Or turn it back into the model for Eloquent and have Eloquent persist it. But it's totally separated from the application logic. And then inversely, if we go to, you'll see, okay, so the difference is I'm on a different port because it's a different web server, and I'm at a different endpoint. This is a straight file. This is Laravel. Recipe rate, same thing happens. Rating 0 to rating 5 if I change it. So, and nothing changed there. I can go into, for example, my use case. Write in the recipe and say, we now allow ratings up to 10. Where's that? Guys, I'm losing my mind. Oh, sorry, I'm not in the use case. Am I? Entity, sorry. That was one layer. Still trying to get all the terminology right in my own head. All right, so we can now do 10, which means when we refresh our browser, we're now allowed to set that rating. Okay, so this could be different applications. The entities could be in a shared library between multiple applications. One could use Laravel, one could use CodeIgnite or any other framework. And you've got true encapsulation and one testable source of truth, and you're able to pivot away as you see fit. And that's it in general. So that's the presentation. Any questions?
Did you get into exception handling at all?
No, I didn't talk about that. Yeah, no, my version of exception handling was telling the function in the doc blocks that it throws an exception. So my IDE didn't yell at me. Yeah, no, this is as far as I could get in a week. I just finished reading the Clean Architecture book like a week ago. There are parts that I don't totally agree with, so it was like contending with that to build this thing up. So, but this I have seen in lots and lots of projects that you are muddling your business logic in all sorts of layers of the application, and it's like, well, I've seen it in the view. I've seen business logic in views where it's like, if it's under less than this, show this many stars. It's like, that really doesn't belong there at all. So, anything else?
Unless it's the exception to the rule, maybe.
I mean, you'd have to really sell me on it, to be honest. Like, there's probably a better place. There is definitely a better place. Views should be dumb. Like,
Yeah, I agree.
totally behind an interface. The same data could go over an API to a view front end and consume it without much business logic on the view end, kind of thing. Cool. All right, that's that. You want to stop the stream?
Are we done?
We're done. All right, how long
See you
was
later.
that? We started at, it was about half an hour. Yeah. Definitely have more content for that one later.
By the way, I think